Let's solve Unit 10 Artificial Intelligence questions. What is the generic structure of multi-agent system? MAS. So it is given as multi-agent system. Here from this term we can understand that there are multiple agents involving in a system. So single agent with multiple objectives will not be the option. Multi-agents with a single objective. You cannot define the objective for multiple agents at a time. When there are multiple agents, each will have an objective, each will do the task that it has to do. Maybe they can communicate about their task with each other, but they cannot work towards a single objective. So they are asking in terms of generic structure. So this will also not be an option. And if you take the fourth option, multi-agent with two objectives, they are quantifying the number of objectives, which again will not be an answer. So multi-agents with diverse objectives, it means variety of objectives and communication abilities. As I said earlier, each may have a different objective and they can communicate with each other about it. Multi-agent system structure will be multi-agents with diverse objectives and communication abilities. Option 3 will be the right answer. Next question. A dash point of fuzzy set A is a point x that belongs to capital X at which mu A of x is equal to 0.5. So they have given a specific value here. A crossover point of a fuzzy set is a point at which mu value of A of x is equal to 0.5. So this is a direct statement question. Option number 3 will be the right answer. Crossover of A is equal to x for which mu A of x is equal to 0.5. This is how it will be given. Next question. In a genetic algorithm optimization problem, the fitness function is defined as f of x is equal to x square minus 4x plus 4. Given a population of 4 individuals with values of x 1.5, 2.0, 3.0 and 4.5. What is the fitness value of the individual that will be selected as the parent for reproduction in one generation? We have to calculate the fitness value using this fitness function. What is a fitness function? A fitness function value quantifies the optimality of a solution. The value is used to rank a particular solution against all other solutions. When you want to assign rank to a set of values, obviously the one with larger value will be assigned the first rank, and that will be the individual who will be selected as the parent for reproduction. Now let's get into the calculation. The first value of x is 1.5. So f of 1.5 is equal to 1.5 the whole square minus 1.5 into 4 plus 4. 1.5 into 1.5 will give 2.25 minus 1.5 into 4 will give 6.0 plus 4. 2.25 minus 2. So minus 6 plus 4 will give minus 2. This is equal to 0.25. The next value of x is 2.0. So let's take it as 2. 2 square minus 4 into 2 plus 4. 2 square is equal to 4. 4 into 2 it is 8 and then plus 4. 4 plus 4 will give you 8. 8 minus 8 will give you 0. Next we have f of 3. So instead of 3.0 I am just making it as 3. 3 square minus 4 into 3 plus 4. This is equal to 3 square is 9. 4 into 3 is 12 plus 4. 9 plus 4 is 13. 13 minus 12 will give you 1. Next value of x is 4.5. 4.5 the whole square minus 4.5 into 4 plus 4. This is equal to, we will do a simple calculation here. I will take out 4.5 from this. So 4.5 into, now one more 4.5 is here, minus 4 is remaining here. This is actually easy for us to calculate. That's why I took, instead of multiplying 45 into 45 and adjusting the points, we can go with this option. So this will be 4.5 into, what is 4.5 minus 4? It is 0.5, then plus 4. So this will be 4.5 into 0.5 will give 2.25. Then this plus 4 will be here. So 2.25 plus 4 will give 6.25. Now you have 0.25, 0, 1, 6.25. Just arrange it in decreasing order. So the largest value is 6.25, then we have 1, then we have 0.25, then we have 0. So which fitness value of the individual ranks first? So option number 4, 6.25 will be the right answer. This is the fitness value of the individual who will be selected as the parent for reproduction in a generation. Next question. In a feed-forward neural network with the following specifications. So let's understand the structure of the neural network now. Input layer has 4 neurons. So let's take this as the input layer. 1, 2, 3, 4. Hidden layer has 3 neurons. This is the hidden layer. 1, 2, 3. Output layer has 2 neurons. Using the sigmoid activation function for given input values. So they have given the values of the input layer. So if this is going to be taken as x, then we can name this as x1, x2, x3 and x4. The values are given respectively 0.5, 0.8, 0.2 and 0.6, as well as the initial weights for the connections. So far we have solved problems like there will be a set of neurons here and again a neuron for the output. So eventually we will have one weight for each. Then the x values will be x1, x2 and x3, and here we will have w1, w2 and w3. What we will ultimately do is we will actually find the product of xi and wi and then sum them together. So I is equal to 1, 2, 3. We will multiply x1 into w1, x2 into w2, then x3 into w3 and add all these 3 together. So this will give the value of this particular neuron. You can see all these input layer neurons are connecting to a single neuron here. So this is the case of this example. Here also we will use the same function, summation of xi into wi, to calculate for a particular neuron. But here you have 4 neurons in input layer, 3 neurons in the hidden layer. Let's take hidden layer as H1, H2 and H3, and this is the output layer. Let's take it as Y1 and Y2. Now they have given W1, W2, W3 as input layer to hidden layer weights. So how will you do this? From X1, X2, X3 and X4, I have to connect to H1. This weight is given by W1. So you have 4 values, 0.1 for X1 to H1, for X2 to H1 you have 0.3, for X3 to H1 you have 0.5, for X4 to H1 you have 0.2. Then the next weight is X1 to H2, X2 to H2, X3 to H2 and X4 to H2. This is given by W2 array. 0.2 is for X1 to H2, 0.4 is for X2 to H2, 0.6 is for X3 to H2, 0.2 is for X4 to H2. Then W3 is given for X1 to H3, X2 to H3, X3 to H3 and X4 to H3. This is given by the array W3. 0.3 is for X1 to H3, 0.5 is for X2 to H3, 0.7 is for X3 to H3, 0.2 is for X4 to H3. This is how they are given from input layer to hidden layer weights. Now let's see the other weights. Hidden layer to output layer weights. How will you interpret this? So H1 to Y1, H2 to Y1 and H3 to Y1 is given in W4 array. So 0.4, 0.1 and 0.3 respectively from H1, H2 and H3. And again we have W5. So this will be H1 to Y2, H2 to Y2 and H3 to Y. This is given by W5 array 0.5, 0.2, 0.4 respectively from H1, H2 and H3 to Y2. So this is how you have to do. Now I have given you the overall structure. Let me explain this once in Tamil. நமக்கு 4 இன்புட் லேயர் நியூரான்ஸ் இருக்கு. ஸோ 4த்துக்குமே எக்ஸ் வேல்யூ இந்த அரேலேருந்து எடுக்கணும். ஒரு எக்ஸ் வேல்யூ வந்து ஹிடன் லேயரோட கனெக்ட் ஆகியிருக்கும். ஃபர்ஸ்ட் ஹிடன் நியூரானுக்கு நமக்கு 4 இடத்துலேருந்து வேல்யூஸ் வரணும். x1, x2, x3 அண்ட் x4லேருந்து. ஸோ இந்த 4 வேல்யூவை தான் அவங்க W1ல கொடுத்துருக்காங்க. அடுத்தது H2க்கு நமக்கு 4 வேல்யூ வரணும். எங்கேருந்து வரணும்? x1லேருந்து x2லேருந்து x3லேருந்து x4லேருந்து வரணும். அது W2ல கொடுத்துருக்காங்க. அதே போல் H3க்கு போக வேண்டிய 4 வேல்யூவும் W3ல கொடுத்துருக்காங்க. இதே மாதிரியே நமக்கு 3 ஹிடன் லேயர் நியூரான்ஸ்லேருந்து 2 அவுட்புட் லேயருக்கு போகிற வெயிட்ஸ் கொடுத்துருக்காங்க. அப்போ Y1க்கு நமக்கு H1, H2, H3 3 நியூரான்லேருந்து வருது. அதை W4லையும், Y2க்கு H1, H2, H3லேருந்து 3 நியூரான் வருது. அதை W5லையும் கொடுத்துருக்காங்க. இதுக்கப்புறம் நம்ம எப்படி அதை காம்ப்யூட் பண்ணுறதுன்னு பார்ப்போம். ஸோ the question now is, what is the output of the output layer when the given input values are passed through neural network? Round the answer to 2 decimal places. So these are the values x1, x2, x3 and x4. I have placed the x array here. Then W1, W2, W3 I have placed in the respective column of x. So when I have to map x1 to W1, I will use 0.1, x2 to W1, I will use 0.3 and so on. So let's start working now. So this is the input layer neuron. Let's write the values. It is 0.5, 0.8, 0.2 and 0.6. Now we will have the hidden layer neurons. For H1 we have to take only W1 values. For H2 we have to take only W2 values, and for H3 you have to take only W3 values. X1 to H1 is given as 0.1. Then X2 to H1 is given as 0.3. Then X3 to H1 is given as 0.5. Then X4 to H1 is given as 0.2. We have to find the product of x and w respectively and then sum them together. So for H1, x1 into w1 first value plus x2 into w1's second value, then x3 into w1's third value plus x4 into w1's fourth value. So what is x1? 0.5. What is the respective W1 value? It is 0.1. Plus what is X2? It is 0.8. What is the W1 value we are taking here? It is 0.3. Plus what is X3? It is 0.2. What is the W1 value? It is 0.5. Plus what is X4 value? It is 0.6. The respective W1 value will be 0.2. What is 0.5 into 0.1? It is 0.05 plus 0.8 into 0.3 will give 0.24 plus 0.2 into 0.5 will give 0.10 plus 0.6 into 0.2 will give 0.12. When you add this, you will get a value of 0.51. So H1 will have a value of 0.51. Now we will calculate for H2. So x1 to H2, the value is 0.2. So we will calculate for H2 here. H2 is equal to 0.5 that belongs to x1 and W2's value will be 0.2 plus x2 to H2 is 0.4. So x value is 0.8 and the respective W value is 0.4 plus x3 to H2 is 0.6. X3's value will be 0.2 and the respective W2 value will be 0.6. plus x4 to h2 will have 0.2. So x4's value is 0.6 and the respective w value will be 0.2. 0.5 into 0.2 will give 0.10 plus 0.8 into 0.4 will give 0.32 plus 0.2 into 0.6 will give 0.12 plus and 0.6 into 0.2 will again give 0.12. This is equal to 0.66. So H2 has a value of 0.66. Now we will move on to the H3 neuron. X1 to H3 has a value 0.3. So we will calculate here. X1 is 0.5 and the respective W is 0.3 plus X2 to H3 will have 0.5 as the weight. So X value will be 0.8 and the respective weight will be 0.5 plus X3 to H3 will have a value of 0.7. We will multiply x3 0.2 and the respective weight 0.7 plus x4 to h3. It is 0.2. So 0.6 is for x4 and the respective weight is 0.2. 0.5 into 0.3 will give 0.15 plus 0.8 into 0.5 will give 0.40 plus 0.2 into 0.7 will give 0.14 plus 0.6 into 0.2 will give 0.12. When you sum up, you will get a value of 0.81. So H3 will have a value of 0.81. Now we have found the value of the neurons H1, H2 and H3 which are a part of the hidden layer. So X is a part of input layer. Now we have to do the same kind of calculation from hidden layer to output layer. So as I explained earlier, now this is going to be like your X value and you have to multiply it with the respective weights accordingly. So remember this formula, summation of xi into wi. Now this will be summation of hi into wi. So let's start. H1 to y1 will have a value of 0.4. So y1 is equal to 0.51 into 0.4 plus H2 to Y1 will have 0.1, 0.66 from H2 and the respective weight is 0.1. Then H3 to Y1 will take the value 0.3 plus 0.81 belongs to H3 and 0.3 is the respective weight. 0.51 into 0.4 will give 0.204 plus 0.66 into 0.1 will give 0.066 plus 0.81 into 0.3 will give 0.243. When you add all this, you will end up with 0.513. So the value of y1 will be 0.513. Now we will compute for h1 and y2. So we are taking 0.5. So y2 is equal to h1's value is 0.51 and then we are multiplying it with the respective weight. Then h2 to y2, it takes the value 0.2 as weight. So 0.66 into 0.2 plus h3 to y2. This will take the value 0.4. So 0.81 from h3 into 0.4 as the respective weight. 0.51 into 0.5 will give 0.255 plus 0.66 into 0.2 will give 0.132. 0.81 into 0.4 will give 0.324. When you sum these three, you will get 0.711. So the value of y2 will be 0.711. So let's get into the question again. The input layer has 4 neurons, hidden layer has 3 neurons and output layer has 2 neurons. Using the sigmoid activation function for the given input values, the final value of y1 is 0.513 and y2 will be 711. Usually after the output layer there will be an activation function. You should have seen in the neural network structure. Now the activation function has to be used for both y1 as well as for y2. So sigmoid activation function is equal to 1 divided by 1 plus e power minus x. We can actually calculate this only using a calculator. So get the negation of x, then find e power minus x, then find 1 plus e power minus x, then divide. This is how you have to find it out. There is also an alternate formula you can use. It is e power x divided by e power x plus 1. So you have to find e power x first, add 1 to it, then you have to divide both these answers and find this. This is the usual function they used to say. Take the summation of weight into the input value. So we used to say x into w. So this activation function has to be applied on this particular value. This will give the output actually. Here we have 2 neurons in the output layer. So we have to calculate activation function for y1 as well as y2. The sigmoid activation function value for 0.513. This is actually y1's value. The value will be equating to 0.62. So this is S of y1. Then S of y2 is equal to 0.711. This value will be equating to 0.678, something like that. So we can approximately use 0.68. So once you use the value of E, you will have more number of numbers after the decimal point. That's why they have given round the answer to 2 decimal places. Option number 1, 0.62 and 0.68 will be the right answer. So this is for y1 and this is for y2. That's why they have given 2 answers here. This is how you have to solve a neural network problem, and this is how you have to find the output of the output layer. If they have not mentioned about sigmoid activation function, the problem will stop here. I want to add one more point here. I have seen few solutions where they have applied activation function in hidden layer as well. Sigmoid or logistic function should not be used in hidden layers as it makes the model more susceptible to problems during training. That problem will be called as vanishing gradient problem. This problem will occur when you train the neural network using backpropagation method. When you apply activation function in the output layer, the values of y1 and y2 are 0.62 and 0.68. What happens if activation is applied in the hidden layer as well as in the output layer? At that time also you will get 0.62 and 0.68. So if you want, I can even give you the values of H1, H2 and H3 after applying activation function. This is just for your reference. H1, when I apply sigma function on 0.51, I'll get a value of 0.6248. For H2, when I apply sigmoid for 0.66, I get a value of 0.6592. And for H3, when I apply it on 0.81, I get a value of 0.6921. Now you have to use W4 with these values. So what is the output that you get for y1 and y2? Y1 you will get around 0.52347. Y2 you will get it around 0.72108. Now when you apply sigmoid activation function, you get the same result. But I'm just giving you the reason why I have not used activation function in the hidden layer. So if you take multiple neural networks books, sometimes the activation function would have been applied to the hidden layer. Sometimes you will have different activation function. One activation function for the hidden layer and another activation function for the output layer. You just understand the function of sigmoid activation function. It will take the input from the previous hidden layer and then squeezes the output between 0 and 1. So it is 0.62 and 0.68 in this case. When there are multiple hidden layers, it takes from the hidden layer that is next to the output layer. So that's why I have not used, and I am giving you an explanation for why I have not used it. Next question. Which of the following are commonly used parsing techniques in NLP, natural language processing, for syntactic analysis? So what are the parsing techniques in NLP? We have top down early style parsing. Then we have bottom up left corner parsing. So here option A, top down parsing, can be taken. Then bottom up parsing can also be taken. So early style parsing is also a technique. Since we find the name similar, we will also include option E. So what is statistical machine translation? SMT deals with automatically mapping sentences in one human language into another human language. So statistical machine translation will not be there in this parsing technique. And dependency parsing is also a parsing technique used in NLP. We will rule out only option D. So option D means 1 and 2 will be taken away. 4 will also be ruled out. In that case, we include A, B, C, E only as the answer. Option number 3 will be the right answer. Next question. In the content of alpha beta pruning in game trees, which of the following statements are correct regarding cutoff procedures? We have already learnt about alpha beta pruning in many previous year question papers. So using that knowledge, we will try to find out which statements are correct and which statements are wrong. So let's start with A. Alpha beta pruning can eliminate subtrees with certainty when the value of a node exceeds both the alpha and beta bonds. This is perfectly true. It means when the node exceeds those alpha and beta values, the entire subtree can be eliminated. Alpha beta pruning means you are removing something from searching the solution. So you are eliminating the subtree completely. The second statement, the primarily purpose of alpha beta pruning is to save computation time by searching fewer nodes in the same tree. Yes, when you eliminate the subtree set completely, you obviously save the computation time by searching only fewer nodes in the same tree. So you take a game tree like this and you have lots of nodes like this here, and similarly you have lot of nodes like this. When you are going to eliminate this subtree completely, you have only fewer nodes to search. So in that case, we can say B is also true. The C statement. Alpha beta pruning guarantees the optimal solution in all cases by exploring the entire game tree. This statement is actually contradicting A and B statements. And when we say alpha beta pruning, pruning means you are eliminating certain parts of the game tree. But here the statement is saying it is going to explore the entire game tree, which is totally wrong. So C is wrong. Once we find that C is wrong, 3 options will be ruled out at a time. Option 3 will emerge as the right answer for this question. Let's check D statement. Alpha and beta bonds are initialized to negative and positive infinity respectively at the root node. So this is also correct. Alpha will be initialized to negative value and beta will be initialized to positive infinity value. So D is perfectly right. So when this initialization happens at the root node, obviously there is a chance that the complete subtree can be eliminated. It can be pruned and only this subtree can be searched. So this says that you are going to search only fewer nodes and this saves computation time, and this opposes the idea of exploring the entire game tree. Next question, match list 1 with list 2. Let's take greedy best first search. It is incomplete even in a finite state space. So this is the statement that is going to help you in this match. A will be mapping to 2. We will rule out 3 and 4. Next is A star. A star usually runs out of space long before it runs out of time. The computation time is not the main drawback since it keeps all generated nodes in memory. So the main drawback here is space. Which option is actually correct for A star? Computation and space complexity is too light. I mean, they are the main concern for A star. So B is mapping to 4. From this we can say 2 is also ruled out. Though computation time is not the main drawback, they say before it runs out of time, it actually runs out of space. Then we have recursive best first search. So that is what is RBFS. The space complexity is linear in the depth of the deepest optimal solution. When we say something as O of n, we say this is linear. The space complexity is big O of D, where D is equal to depth of the deepest optimal solution. So when they say it is linear in the depth, it means it is big O of D. So C is mapping to 1. Then we have simplified memory bounded A star, that is SMA star. Simplified memory bounded A star is optimal if any optimal solution is reachable. Otherwise, it returns the best reachable solution. There is a case where if optimal solution is reachable, that algorithm is optimal. Otherwise, it does not end the algorithm without any result, but rather it returns the best reachable solution. So here we can say optimal if optimal solution is reachable, otherwise return the best reachable optimal solution. So whatever it is best reachable, that becomes the optimal solution. So D will be mapping to 3. Option number 1 will be the right answer. I have taken the statements that is going to support the list 2 part. I have not taken any other details because we have already discussed a lot about these algorithms in previous year question papers. Next question, match list 1 with list 2. We see B, D, M values here. Let's understand what are these. B is the branching factor, D is the depth of the shallowest solution, and M is the maximum depth of the search tree. Now we will see about the algorithms. Best first search is an instance of the general tree search or graph search algorithm in which a node is selected for expansion based on an evaluation function f of n. A star search expands nodes with minimal f of n value. So f of n is equal to g of n plus h of n. So they say from start node to a specific node and from specific node to the goal node. A star is complete and optimal provided that h of n is admissible for tree search or consistent for graph search. Then we will see about hill climbing. The hill climbing search algorithm. This is called the steepest ascent version. This is simply a loop that continually moves in the direction of increasing value, that is uphill. At each step, the current node is replaced by the best neighbor. That means the neighbor with the highest value or lowest heuristic h will be selected. So let's start matching. For best first search, B will be mapping to 1. It counts both the branching factor as well as the depth of the solution. So big O of B power D will be the answer for BFS. So regarding A star, they would have mentioned it as big O of B delta or big O of B power T. B will be the branching factor. Del symbol is actually the maximum absolute error. In best first search, we go with tree or graph search. So it is directly taking B power D. And here for A star search, we can map it to 4. The reason is it is the maximum depth of the search tree where we can use B power M. So instead of B power T, it is B power M. So we have two options matching here. We'll rule out 3 and 4. Now coming to hill climbing algorithm. At each step, the current node is replaced by the best neighbor. So how do we find the best neighbor? They say it's the neighbor with the highest value or lowest heuristic edge. It means by a single calculation, we will be able to find the best neighbor. So hill climbing will take the third option, big O of 1. A will be mapping to 3. Why do we map hill climbing to big O of 1 is because by calculating the heuristic h, we can find which has the lowest h value and we can pick up that neighbor as the best neighbor. It is actually a loop where you move in the direction of increasing value. So at each stage you have to pick the highest value and keep moving up the hill. Or you have to choose the lowest heuristic and just keep moving up the hill. So when I want to travel to a hill like this, I have to choose the best neighbor to move forward, then again the best neighbor to move forward. At a time I am going to choose only one. That's why we are mapping hill climbing to big O of 1. We will rule out option 2. Option 1 will be the right answer. Now depth first search. So if you are sure about depth first search complexity, then you can map D to 2. Next question. Arrange the following encoding strategies used in genetic algorithms in the correct sequence, starting from the initial step and ending with the final representation of solutions. What is encoding actually? The process of representing a solution in the form of a string that conveys necessary information is called encoding. First one is binary, representing a gene in terms of bits, that is in terms of zeros and ones. Then we have real value encoding, representing a gene in terms of values or symbols or string. In some other question paper, I have actually shown you the representation of binary encoding, real value encoding, integer encoding, then permutation encoding too. Then we have permutation encoding, otherwise called order encoding, representing a sequence of elements. This will be like 0, 1, 1, 0 in such representation. Then real value encoding will be in the form of decimal numbers. Then permutation will have 4, 5, 1, 2 and 3. So for the traveling salesman problem, this represents the cities that have to be visited. So this was one of the example I think I would have given in that video. So let's learn about gray coding. A gray code takes a binary sequence and shuffles it to form some new sequence with the adjacency property. A gray code representation seems to improve a mutation operator's chances of making incremental improvements. Usually a gray code is formed by just shifting only one bit. In a gray coded string, fewer mutations lead to a change this large. Even a single bit modification will make a big change. That is what they are trying to say. Real valued encoding is used when potential solutions contain continuous values like this that cannot be encoded easily with binary encoding. So we will choose real valued encoding for cases where binary encoding does not work. Binary encoding is like whether it is present or not, 0 or 1. But real value has continuous values. Encoding schemes where fitness depends on order, we say it is permutation encoding. As I said earlier, traveling salesman problem deals with the order of cities being visited in this example. When the fitness depends on value and order, we go with binary encoding, and when the fitness depends on value only, we go with real value. Actually, when you get into the genetic algorithm phase, you will come across three operators named selection, crossover and mutation. This permutation encoding is possible during crossover stage, and as we saw, this gray code representation will improve a mutation operator. We will start with permutation. Permutation encoding is about ordering. Think it is a solution and we will just find an ordering. So we will start with permutation. So we are starting with C. After getting an order, we are actually trying to shuffle to form new sequence with adjacency property. By shuffling, we are having more chance of making incremental improvements. So in that way, from permutation, we move to gray coding, which is option D. When we have gray coding, it is automatically a binary sequence. We go for binary encoding from gray coding. This is not encoding, this is just gray coding. With the permutation string, I am trying to find out the gray code. From the gray code, I am trying to do binary encoding. So this is A. When binary fails, we can go with real valued encoding strategy, where this is option B. Since the official answer is declared as option number 3, this is how we can perceive it. Next question. Arrange the following steps in the correct sequence for applying an unsupervised learning technique, such as k-means clustering is to a data set. So let's see the algorithm. First, we have to specify the number of clusters k to be assigned. Specify the number of clusters to partition the data into. D will appear first. So we are specifying the value of k. 2 and 3 will be ruled out. The next step, randomly initialize k centroids. The A statement, randomly initialize cluster centroids. So we have A in the next order. So this is initialize centroids of those k clusters. So we can rule out even option 4. From this we can easily say option 1 will be the right answer. We'll just complete the steps. After initialization, we have a repeat until. So what is the next step? Assign each point to its closest centroid. This is the B point. Assign each data point to nearest cluster centroid. So we have B. Then compute the new centroid of each cluster. So update the cluster centroids based on the mean of data points assigned to each cluster. So they have given this as mean. So next comes step C. Here we are assigning points to centroid, and here we are computing new centroid. Then after that, repeat steps B and C until convergence criteria are met. So this is under a loop. So these two steps, B and C, assigning and computing, are to be repeated until convergence criteria are met. So repeat until the centroid positions do not change. Until they are changing, you need to compute it again and again. Once they do not change, you can stop the algorithm. That is what this repeat until says. So E will be the next step. It says repeat B and C till some criteria is met. So that criteria is the centroid positions do not change. The algorithmic steps of k-means clustering has been already asked in some other question paper, and if you want to know about other unsupervised techniques and supervised techniques, you can always refer to the machine learning series available in my channel. The series is available in Tamil language. Even if you don't understand Tamil, you can still follow the video because the content is in English. So option 1 will be the right answer. D, A, B, C, E is the correct order of the steps. With this, we are completing Unit 10 solutions.